Hi, in this video we're going to look at thermoregulation. So we're looking at the impact of temperature on performance and how we can transfer heat. And we're looking at these four methods: conduction, convection, radiation and evaporation. So it'll take you back to GCSE science. Our body will want to regulate its core temperature and maintain it. The core involves the head, the chest and the abdomen, this part here. Our head because of our brain and our core temperature here because of all of our major organs. Our body likes to stay about 37 degrees regardless of its conditions. So this winter, when we're all playing in the snow, our core temperature will want to remain at around 37. In the summer, when we're at about 28 degrees and we're in our shorts and t-shirt, our body will want to remain at about 37 degrees. That's our core temperature. And our body will have processes to either conserve heat, so to preserve it, to keep it, or if we're too hot, to try to get rid of it. And it's those processes we're about to learn. 1% drop either way can affect your performance. So initially, going up by 1 degree and going down 1 degree might just be simple things like a mild headache or tiredness or irritability. If we go beyond this, so we go above 40 degrees, we're going to reach the condition called hyperthermia. If we go below, down as low as 32 degrees, we can have hypothermia, both of which can be fatal at around those temperatures. So our body uses thermoreceptors, which we've spoken about before, and they detect a change in the temperature of the skin and the blood temperature. They report all of this information to the hypothalamus, which is up in the brain, and the hypothalamus then controls our core temperature, and it will do things like cause blood redistribution, so for the blood to go to the skin instead of the working muscles, so we can get rid of heat. Or it may redistribute, so it takes the blood away from the extremities to conserve and preserve our heat and keep it in the core. It may increase your heart rate, as say a side effect of being too hot is that you can be dehydrated and your blood flow can go down. The hypothalamus then will detect this and increase your heart rate to compensate for that slow blood and that lack of oxygen delivery. Heat can reduce performance by causing dehydration. It impacts those participating predominantly in aerobic activities, so those activities that are lasting for a prolonged period of time. It doesn't really have too much impact on activities like a shot put throw. So let's look at our first method of how we can lose heat or conserve it to keep our core body temperature around 37. So the first method is called conduction, and this is the movement of heat through contact with something, and that can be the air here. So this man's skin is in contact with the air, and underneath the water his skin is in contact with the water, strangely enough. So we've got sporting examples could be air or water. Heat loss in water is 25% quicker than in the air, and that's to do with contact and the nature of the molecules, essentially, which we don't need to know for this specification. We need to know, though, that if the air and the water are the same temperature, 25% quicker heat loss in the water. So it means that if we are doing this open water swimming, that we need to take precautions, and you can see that this person has their wetsuit on covering their entire body, and that will be to preserve their heat. So even if they're the same temperature, they're the air and water, your heat loss is 2 to 4 times quicker. So I've put open water swimming as an example. So our next method is convection, and this is airflow over the skin. So it's not the contact this time, it's the flow of air over the skin. Now it looks like a nice still day there, so there will be some breeze that will take the heat away from this gentleman's skin. If it was a windy day and the airflow was much greater and much quicker, it would obviously take the heat away from the skin at a faster rate, and you would drop your core body temperature quicker. Hence it's colder on a windy day than it is on a still day. So it's airflow passing over the skin and taking the heat away. If the air is fast, heat loss is quicker. So if you are running or cycling, which is going to be faster, you're going to lose heat quicker than if you were walking. Radiation is our next method, and this is our main method of heat loss. This is the main way in which our body gets rid of heat. So when we're exercising, our core temperature will increase, and this is the main method to get rid of that excess heat. It transfers to cooler objects, not in direct contact. So it's not conduction. It transfers to cooler objects, and I know this sounds crazy, but if the wall is cooler than your body, then it will radiate to that cooler area. If you imagine on a hot day, if you lean against a radiator that's not turned on, you are going to transfer your heat onto that cold radiator really quickly. That's conduction, because you're in direct contact. If you move away from that radiator and just have a t-shirt on and your skin, and you're a couple of inches away from that radiator, it would then be radiation, but your heat will be radiating into that metal. High body fat, so someone with a high level of body fat actually insulates the body, because it gives you the fat underneath the skin all the way around. I'm not saying this gentleman is fat in any way, but you've got the skin under the level, the fat, sorry, under this layer of skin. That means that radiation is not effective for people who have high body fat percentage, because the heat then couldn't escape out. It insulates it. So it means that people, when they are trying to exercise, if they have a high body fat percentage, will find it very uncomfortable, because they'll get very hot very quickly. And we know if we're very hot that our heart rate's going to increase, our breathing rate's going to increase, and we can feel generally quite unwell. This is happening, this radiation, it's happening all the time. So you're always radiating heat out of your body if your body temperature is warmer than the surroundings, which they generally are. Our final method is evaporation. So this is related directly to sweating. So we know that that's a cooling system of our body, and it's the main heat loss during exercise. So radiation was the main method of heat loss, just normally, just walking around, just sitting in the classroom. This is our main method of heat loss during exercise. It has a cooling effect when the water on our skin is evaporated into hotter conditions. So the sweat is layered on the skin here, and it evaporates out into the atmosphere. As this sweat is evaporated and our skin dries, it takes the heat with it, leaving a cooling effect on our skin, and obviously reduces our core temperature as well. If the conditions are dry and warm, we have evaporation much more effective, because the atmosphere is not humid, it hasn't got water particles in it. So if it's drier, it will be able to evaporate because there's less water particles in the air. If you're in humid conditions, I don't know whether any of you ever been over to a humid country, so somewhere like Miami, for example, in our summertime is very humid, and it has rainstorms most of the time. What this has is around you all the time is a high percentage of water vapour. So actually sweating does occur because you get hotter because the temperatures are increased, but you can't evaporate the sweat off your skin. So you just end up, well, quite sweaty and quite disgusting. But if you're in a dry place, a dry heat, then that sweat will evaporate quite nicely from you. So in humid conditions, there's a decreased level of evaporation, and if you're just in warm, dry conditions, you get increased evaporation. So it's more effective for us, really. So let's look at the factors affecting heat loss. And of course, we need to manipulate this when we're exercising so we can have efficient training sessions. So temperature differences between the two areas. If there's a large difference between the hot and cold, there's a greater loss of heat. So if this water is a lot colder than his skin, he will lose heat quicker than if he is in a heated swimming pool, and so a couple of degrees hotter, the heat loss from his body will be reduced. There's minimal difference, obviously, if he was in a pool, so slow loss of heat. Water, cold seats, equipment on the skin causes heat loss via conduction. So a spectator sitting on a seat in a stadium, a cold seat on a stadium, will lose heat quicker than a spectator standing up and losing it just to the air. If you're in water, like we've discussed, you're an open air swimmer, you're going to lose heat quicker than if you are just out in the air. You could be holding equipment, so you could be holding a javelin, and the heat from your hand can go into that javelin if the javelin was cold, for example. It could be the handlebars of your bike or for your seat if they are very cold. We can use this to our effect by having heat pads, and we can gain heat by conduction, so we can hold on to those heat pads that we put in our gloves to keep us warm. And it's still conduction, but this time we're taking in the heat. Wetsuits are beneficial because they act. Do you remember us talking about this fat layer over the top? If you have them, it insulates. A wetsuit's like our artificial fat layer, like a seal who has blubber to keep them warm. So our wetsuits go over our skin, obviously, and they do allow water in. But what happens is that water soaks in and it's cold initially, but soon the heat from your body heats that water up, and that water is trapped in the suit. It doesn't really get replaced by cold water unless you're put against a real strong current. So it traps the heat, and it reduces the effect then of conduction because it stops that transfer of that water going out and being replaced by cold water, and it reduces convection. So it stops the air from taking away. It stops it touching the skin. So it reduces convection as well. So the wetsuits are really useful for keeping warm. Clothes, obviously, if we're going out for a run, something like that, we've talked about layering and wicking outfits. So these are special running t-shirts that if you look under a microscope, if this is the inside layer of your t-shirt against the skin, and this is the airflow on the outside, they have little channels in them, I mean the microscopic channels, that take the sweat away and put it onto the surface, but they're so small that it allows evaporation but not from the skin, so it doesn't have a cooling effect. And convection also occurs, but because it's not against the skin, you're not going to feel it, so it conserves heat. So it can trap heat and insulate, so we can get heat trapped in here and the airflow can't get to and the evaporation can't happen. So it preserves our heat here. Here we go, convection by reducing airflow. Clothes and blankets insulate the heat by radiation. That's these red marks that I've put there. That's radiation when the heat comes from the skin there. But this time we're trapping it with clothes or a blanket. And this one I've mentioned, the wicking clothes take the sweat away from the skin. So this is your sweat coming out here, and then prevents evaporation from the skin, which means that you don't get that cooling effect. Hope that makes sense. That's the end of D4.